Everybody prepared to, well, here's our learning targets for today, right? We're going to graph some more hyperbolas. We're going to complete the square and talk about eccentricity. But today we're also going to be writing equations of hyperbolas. The first one we have is a review question. Is this at the top of the page? I hope. Okay. So very carefully, we need to examine our green sheet and figure out what A and B are for those formula users. A is not always bigger than B this time, right? A is what's underneath the positive term. So the y squared is the positive term here. So if I write this, it'll say y minus k, x minus h. This would be a squared and this would be b squared, which does happen to turn out to be the biggest number, right? Just trying to make sure everybody is following. All right. So what's h and what's k? Okay, so the vertex is at 1, 0, or the center, sorry. So right here is the center. But the vertices, which way is this one going to open if it starts with a y squared? Up and down, right? It's going to open this way. So the vertices are up and down how much? Well, they're up and down A. Underneath here, A is 4. So if we go up 4, down 4, the vertices have a formula of, I'm guessing, h plus or minus a comma k. Is that right? Which would be 1 plus or minus 4 comma 0. So we will have vertices at 5, 0 and negative 3, 0. Just kidding. Did I count mine wrong? Oh, yep. I totally wrote this wrong. I graphed them right. All right. It's going up and down on the y, so it's h comma k plus or minus a, which is what I did. It should be 1 comma plus or minus 4. So the vertices are at 1, 4, and 1, negative 4. I was getting there. Just caught myself. Okay. How far do we go out the other direction, which aren't called co-vertices anymore? They don't really have a name. They're the ends of the something axis. What's the axis that goes this way? Conjugate, maybe? Okay. How far are we going either way there? Okay, B is 2. So we're going 2 this way and 2 this way. That would be the other whoa, just kidding. That's not 2. Then instead of drawing an ellipse, we draw a box, rectangle, called the auxiliary rectangle. It really should be dotted, but I'm not going to worry too much about that. It's not actually part of our graph. It helps us find the boundaries. Because it helps us find what? What do we draw next? Yes, the asymptotes. The asymptotes are the diagonals here. So we're going to put in the diagonals of this box. Okay, could we come up with equations for those? Okay, we use y minus k equals x minus h. And here is the slope. And that's change in y over change in x. And since it's opening up and down, I'm thinking it says a over b on your sheet. Yes? Say a over b for that one. And it's a plus or minus. So what do we get? Y minus k is just y. Plus or minus a over b. Be careful. It's not 16 over 4. It's the square root of 16 over the square root of 4, which is 4 over 2 or 2. And that should have a plus or minus. And then x minus h was x minus 1. And you can just leave it. All right, so it went through this point and it's going up 2 and over 1. We got all we have left is the foci and the actual graph. Let's graph it first. Where do we put the graph? Yeah, this is the vertex, so it is up here and it should be getting closer and closer to those asymptotes. And it has a branch down here as well, whose vertex is right on the box right there. All right, left with the foci. The foci should be inside the U's, okay? And the formula on our sheet says c squared equals plus b squared this time. So if a squared is 16 and b squared is 4, c is going to be the square root of 20, or roughly 4.5. Is that what we said? But 2 square roots of 5, right? So how do we write the foci? Does it say h comma k plus or minus c on your sheet maybe? So that would be 1 comma 0 plus or minus 2 square roots of 5. Whoa, that's a square root. I don't know what I just wrote. All right, so it would be up here at 4 point something and down here at negative 4 point something. They're just inside of those. All right. Humor me, could we find the eccentricity? E equals C over A. Do we know both of those things right now? C is 2 square roots of 5 and A is 4. So we get square root of 5 over 2. Someone type me a decimal for that. Right, square root of 5 over 2 is the answer. I just want to know approximately what that is. 1.1-ish. Okay, why is it important that we check that? For a hyperbola, eccentricity should be, what does it say on your sheets? Greater than 1. All right, so we got all that from this, hopefully. Evil people, what's going on here? It's those ambiguous people who wrote the worksheet again. I had nothing to do. X squared minus 4x plus blank. But what do we have to do to our y's here? Careful. We have to take out a negative 4, right? Because we want it to be a positive y squared. So we're going to go negative 4, positive y squared. But if we took a negative 4 out of the 24y, we'd have minus 6y. Yep, be real careful. Plus blank. And on the other side, 36 plus a couple blanks. Anybody lost? All right, complete the square on the x's and we get x minus 2 quantity squared, where we are adding 4 to both sides. If we complete the squares on the y's, we bring down the negative 4. Half of y squared minus 6y would make it y minus 3. Squared, square the negative 3 and we get 9. But what did we really add to that side? Negative 4 times 9, which is negative 36. To the positive 36 would be 0. So left on that side is a 4. And then we need to divide everything by 4 because the equation on the sheet said it has to equal 1. Okay. What can you tell me? Tell me one thing. Blurta, tell me anything. Keandra, can you tell me one thing? Sam Dawson, one thing? Sam Procopio, one thing. Yep, this is b squared, so b is 1. You're good. Michael, tell me one thing. Oh my goodness, he's jumping right to C. Square root of a squared plus b squared, so square root of 5 is C. Patrick, tell me one thing. How about just which way does it open? Yes, because the x is in front of the minus, okay? It's the positive part of this, so it's opening this way. All right. Fatih, where's the center? Okay, 2, 3. Melanie, then what? Anything you want after that. Okay, in the y direction, we're going 1 each way. Only 1, okay? But those aren't the vertices, notice. She didn't say they were the vertices, because they're not. Where are the vertices? Madison, can you help me with the vertices? What's the formula when it opens sideways? Okay, so our K was 3, and our H was 2, and our A was 2. So 2 plus or minus 2 would make them at 4, 3, and 0, 3. So 0, 3, and 4, 3, and those are the vertices. What do I do next? Becca? Draw the rectangle, and anybody, it's what's going to help us after that? Is my rectangle too big? Yeah. Yeah, I went to the right 3, thank you. This was supposed to be 4, 2, which is here. Thank you, before I kept going and made it even worse. Okay. Diagonal, badly drawn. Other diagonal, even worse drawn. Let's see if I can make it better. Should be going through the corners, right? And through the center. There we go. That looks a little better. Feel free to use a ruler. And where do I draw the U shapes? Left and right. So over here, hitting this vertex, and not the asymptote, though mine got incredibly close. I'm going to pretend it didn't touch, okay? All right, what do I have left? Need one more thing. Oh, 2 more things. Asymptotes, I need the equation of those. Good job, guys. So it's y minus 3 equals plus or minus change in y over change in x, or b over a on this one. Is that what it says? 1 over 2, right? Because a and b are 1 and 2. And then x minus h, which was 2. And we can just leave it like that. Does that seem right for our... Did it go up 1 and over 2? Or down 1 and over 2? Okay. Foci, though, we're still missing. What's the formula say on the sheets? H plus or minus c comma k, which would be 2 plus or minus square root of 5 comma 3. Anybody got a decimal for me? What's 2 plus square root of 5? Like 4 point something, right? So it's just barely inside here. Now do we have everything except the eccentricity if I asked for it? Eccentricity would be C over A, so square root of 5 over 2. But I'm going to keep going. Are we good? How you feel? Alyssa, kind of got an overview of what we did? All right, excellent. Now, unfortunately, we're going to go backwards and write equations. All right, I always have to draw a sketch because it makes way more sense to me than trying to look at the sheet and decide which way this is opening based on whether the H's and K's match up, okay? If I do a little sketch, tiny little sketch, left 3 down 6, left 3 up 2. If those are the vertices, what does that tell me right away? It opens up and down. From there, I can use the sheet, right? To figure out what I want to know. What's the general form when it opens up and down? Y minus k squared over a squared, whoa, minus, that's a mess, x minus h squared over b squared equals 1. Okay. Can anybody tell me conceptually what a is? A is the distance from the center to what? That's the center. Yeah, to each vertice. I don't know what it says on the sheet. I should have the sheet. It says the vertices are at, when it's opening up and down, the vertices are at h comma k plus or minus a. Well, what do we have to find first? The center. Are we good at that yet? The center is what? Midpoint. I don't care if you do the midpoint of those two or the midpoint of the foci, right? Same thing. Okay, midpoint here, -3 plus -3 is -6 divided by 2 is -3. -6 plus 2 is -4 divided by 2 is -2. Does that seem like it could be right on my little sketch there? All right, so if h and k are -3 and -2, and we figure out what a is, how far is that vertice above the center or below? Yeah, you could have done the difference in the vertices and said that's 2a, right? But it's okay to just do midpoint to here. If this is supposed to equal -3, -6, right? -3. What did they do to this? They went down 4, right? So the distance is 4. Doesn't matter positive or negative because we're going to square it. All right, so tell me how to start this equation. Y minus or y plus 2, as I'm just filling this business in, squared minus x plus 3 squared equals 1. We know one more thing already. What is it? A is 4, so this is 16. Okay, what are the foci going to help us find? Not B, right? They're going to help us find C. The equation for the foci is h comma k plus or minus c. So if the center was -3, -2, and they added c to it, and they came up with one of the foci is at -3, -7, what's c? How did they get from -2 to -7? C is 5. Does this become 25? No. If C is 5, we got to do some hokey pokey in here. C squared equals a squared plus b squared. So we have 25 equals 16 plus b squared. Anybody? B squared is 9. So b is 3, but what do we really want down here anyway? B squared. Bada boom, bada bang, we're done, we got it. Yes? No? Baby? It was a little painful. Okay. Oh, good. Another one just like it. Okay, what do you want to do first? Well, I'm going to sketch because I don't know which way it's opening. -10 up 6, +4 up 6. Ooh, what do you think? Opening left and right. So I'm going to write the general equation down. X minus h squared minus y minus k squared. Because it's opening left and right. Yes? Is that what it looks like on your sheet? Okay. Center. We add the vertices. We get that, which is -3, 6. Anybody coming up with that? So fill that into the equation for me. All right, what else can we do? What is the distance from here to here? Or you could use the center, but the distance from here to here, from -10 to +4 is 14, which is A is 7, yeah. But let's use the recipe. Opening sideways. The vertices are at h plus or minus a comma k. Well, we know h is -3. We don't know a. We know k is 6. And that's supposed to be -10, 6 for one of them. Doesn't matter which one you use. So how far did a make it change? 7, just like we said, right? So where are we going to put 7? 49. Because a is 7. So 49 goes here. What about foci? Anybody tell me what C is just by looking at them? The difference between those is twice the foci, or twice C, I mean. Okay, but if we use the equation, the foci are at h plus or minus C comma k, which would be -3 plus or minus C comma 6, and one of them is at -12, 6. How far from -3 to -12, or if we write that down, we get C as -9. Doesn't matter if it's positive or negative, right? It's a distance of 9. So now what? Does that go over here? No, we need B. C squared is 81. A squared is 49 plus B squared. 81 minus 49. 32. And B squared is what really goes in our equation, not B, right? So we could just leave it 32. Luckily, we don't have to graph that. All right, this one's even easier if you happen to know what the transverse axis is. Well, first of all, I don't know about you. I have to sketch. Okay, 0, 6 is up here. 0, -4 is down here. If those are the foci, it somewhere in a little bit closer is where the vertices are, but it's opening up and down around those foci, yes? So general form, what comes first? Y minus k minus x minus h, and this is a squared and b squared. Okay. You'll need the center, yes? Center equals midpoint, which would be 0, 1, maybe? Got to add 6 and -4 is 2. Divided by 2 is 1. Now what? I can put in 0 and 1 carefully though. Why? This is 0 and this is 1, right? Ideas? What if foci help us find? Foci help us find C. When it's opening up and down, the formula is H comma K plus or minus C. Well, H is 0, K is 1. And one of those foci is at 0, 6. So what's happening here? C is 5. Well, that's great. We need A and B. All right, if I look at my sheet, it says for this kind that a transverse axis is x equals h. Which way would that be running? Transverse axis, x equals is this way, right? So it's measuring here to here if it says the transverse axis is 8. Or if you look at it, doesn't it say on there that it goes through the center? Okay. So how far is this? If that whole thing is 8, how far did they go up and down to those vertices? So what does that tell us? A is 4, and A squared would be 16. I did not put one that says transverse or conjugate axis on the quiz, okay? All right, if A squared is 16 and C squared is 25, then what? C squared equals A squared plus B squared. B squared is 9. So we wound up with y minus 1 quantity squared over 16 minus x squared over 9 equals 1. We're rocking this. All right. This is a little bit tricky, and it's a little bit trickier than the one that's on the quiz. What do you want to do first? Find the center? Okay, that's a good idea. So if we add those x's, divide by 2, add the y's, divide by 2, we get 7, negative 2. Is that right? So if I went over 7 and down 2, I'd be at the center. What else do you know? Over 12, down 2, over positive 2, down 2. Those are the foci. So what is that telling us? It's opening this way, but it's not going through those foci, right? All right. How about the general form when it opens left, right? X minus h squared minus y minus k squared equals 1. A squared, b squared. We can find C. C comes from the foci when it opens sideways. The foci are at h plus or minus c comma k. And our foci, our h is 7, our k is negative 2, and one of them is at 2, negative 2. So 7 plus or minus c equals 2 would make c equal what? Yeah, negative 5, 5 doesn't matter, means c squared is 25. Okay, yeah, this is a harder question than I have on the quiz for you, I promise. This is supposed to be A and B, right? Does it work? For one that opens sideways, this is B over A. Will 3 squared plus 4 squared equal 5 squared? Yeah, we're good. So B is just going to be 3, and A is going to be, or B squared is, B is 3, B squared is 9, A is 4, so A squared is 16. All right, let's put it all together. X minus, what was H? 7 squared minus Y plus 2 squared. The X's are over a 16, the Y's are over a 9, equals 1. Okay. No, that's true. We didn't even need C. Yes, the reason is, guys, what if C squared had turned out to be 50? Okay, then A squared plus B squared wouldn't equal C squared, right? We'd have to figure out, because the thing is the slope could have been reduced. It could have been 6 over 8, okay, which would have made C squared 100, I think. Not 50, I'm lying, but, well, I think we're going to run into one in a second. Maybe, just kidding, maybe not. Okay, what are we doing here? We're supposed to graph this. Where's the center? 50, 35. Oh my goodness. What are we counting by 20s? 20, 40, 60, 80. So 50. And up this way, we're counting by 10s. Just to make life miserable. I feel like we're in science class. Don't you do crazy stuff like that in science class? Count by weird things? 35, 50, 35 is up here. All right, now what? A is square root of 1600. 40, right? 40 times 40 would be 1600. And that's going which way? It's under the X, so it's going left and right, which is 2 boxes, right? Left and right, 2 boxes is 40. Okay, up and down, square root of 2500 is 50, which is up and down, what is 50? A lot of boxes. 1, 2, 3, 4, 50's 4.5 boxes, right? Up and down? Because it's counted by something different? It's counted by 10? So it's 5. I don't know. 5 boxes? 10, 20, 30, 40. We're at 35. If we go up 50, we're at 85. Yes? Okay. If we go down 50 from 35, we're at negative off the bottom. Yeah. I don't know. Okay. If we were to pretend to actually draw this, it should open which way? Had an x squared first, didn't it? So it should open this way. You good, Sam? Okay. All right, then we need foci. That's what they want because there's a seismograph located at the foci of each. We need C. Square root of A squared plus B squared would be 25, 31, square root of 4100. Anybody? Which is roughly 10 square roots of 41, or what? What was the decimal, Madison? Okay. And we're adding that on to what? The center in which direction? The x direction. You can use the formula, but it's 40 plus or minus 10 square roots of 41, or 40 plus or minus 64.03, comma, 35. Okay, that was just too much fun. I just don't even know, because I didn't even figure out how far 64 is. They're counting by 20s, right? So it'd be a little over 3 boxes. 1, 2, 3, somewhere in here. Yeah, the big dot theorem. Okay. All right. A grassy play area is in the shape of a hyperbola as shown. Okay, so is the grass the shaded? I think it's supposed to be. Write an equation that models the curved sides of the play area. Ooh. Where's the center? And it's opening up and down. So y minus k, x minus h. Okay. What does this tell me? If this is 2, that goes under, went up and down, 2 squared, right? How are we supposed to find b? Can we count? We're just going to do this. Pretend that's the rectangle. Does that work if we put those in? I think what they wanted us to do, can we find an ordered pair? What's an, I'm just for fun. What's this ordered pair right here? 2, 4, 6, 8, 0, 8. So what would we do? We're trying to find b squared down here. We'd put in 0, 4, 8. This would be 8. This would be 0. Okay, humor me. 8 minus 4. 4 squared. 16 divided by 4. Okay. 0 minus 3 squared is... Okay, what would we do next? Subtract 4, which would be... Okay, can we get rid of the negative on both sides? Then what? 9 equals 3b squared. If I multiply that over to that side, what's b squared? How could you have counted? Yeah, but that means b is square root of 3. Okay. Anyway, it's the last part of the question says I didn't ask you one like that anywhere ever. In each unit is 3 feet by 3 feet. What is the narrowest vertical width? So in other words, this is how many boxes long? 4, right? And if it's 3 feet for each box, the narrowest part of the play area is 12 feet. That's not making a very big play area. I guess it's at its narrowest. Yeah, it's a very weird shaped park anyway. All right, eccentricity. Oh, I forgot we had all this. We already did this yesterday though, kind of, right? Eccentricity is the distance between the foci divided by the distance between the vertices. Because it's further between the foci on a hyperbola, we get greater than 1. Do you have this on your paper, this little chart already or not? This shows the eccentricity for an ellipse. The eccentricity will always be less than 1, yes? Between 0 and 1 if you want to write it that way. For a hyperbola, the eccentricity will always be greater than 1. For parabola, it has 1 vertex and 1 focus, therefore it's at 1. And eccentricity of a circle, because you have to put the foci right on top of each other. If you treat a circle as an ellipse, it will turn out 0, okay? Because you will find C equals 0. All right. Do you have these two questions? Okay, find the eccentricity. What shape is this? It's a hyperbola. So E equals C over A no matter what, but how do we find C if it's a hyperbola? Square root of A squared plus B squared, which is 25 or 5. What's A? Is it square root of 21 or is it square root of 4? A is the positive, so A is 2. So for example 1, eccentricity is 5/2. Does that work for it to be a hyperbola? Okay, what's going on B? Complete the square for fun. Okay, what can we take out of the x's? 4, x squared minus 8x plus blank equals, what are we taking out the y's? So we have plus 9. What's that telling you it's going to be? Could be an ellipse, right? Okay. What do we get when we complete this square? 4 times the quantity. X minus 4 quantity squared plus 16. Over here we have 4 times 16 plus 9. Okay, which this then is a 25. 9 times 25. 225 minus 253 plus 64. I'm guessing 36. All right, so 4 goes into 36 9 times. 9 goes into 36 4 times. All right, x minus 4 quantity squared over 9 plus y minus 5, that's a minus, squared over 4 equals 1. Okay, eccentricity should be, it's still C over A, but it should be less than 1, right? What's A? On an ellipse, A is always the bigger number, so A squared is 9, so A is 3. And to find C, remember the way it goes? It's A squared minus B squared, so it's 9 minus 4, which is, okay, somebody divide that for us. Square root of 5 divided by 3. What is it? Is that a good news? Should be less than 1, right? Do we need to graph an ellipse just to practice, so we're good? Okay. All right, so the review for quiz, if you didn't already write those down, those are the questions that I'm adding to the homework check, okay? It's on the board. It's in green, though it's kind of hard to read. It's also over there in orange. Okay. Tomorrow I'm going over that review that's in the back. But it's got a lot of questions on it, so we're going to have to go kind of fast. Thursday, you'll have a work day. Because I'm